Hello students, welcome back to the video classes. Today we are going to study some of the important properties of union and intersection. These are very important properties to solve the practical problems. Let me begin with first law or the first properties, that is operations of union. Commutative law. To define the commutative law, one should have two sets. Let A and B are the two sets. Therefore, A union B is always equal to B union A. Such law is called the commutative law. The union meaning is the elements belongs to both the sets. Next, the associative law. To define the associative law, one should have three sets A, B and C. Therefore, A union B union C is always equal to A union B union C. Such law is called associative law. Next, law of identity element. Any set union empty set gives the same set. Such law is called as law of identity element. Here, empty set is an identity element. That is, A union null set is always equal to A. Therefore, phi or null set is called identity element. Idempotent law. A union A is always equal to A. Such law is called idempotent law. Next, law of union. U stands for universal set. Universal set union A is always equal to the universal set. Such law is called the law of union. If these are the important properties of union. Now next, important properties of intersections. Here also we have two non-empty sets A and B. A intersection B is always equal to B intersection A. Such law is called commutative law. And to define the associative law, one should know the three sets A, B and C. A intersection B intersection C is always equal to A intersection B intersection C. Law of identity element. Any set intersection empty set is always equal to empty, or empty set intersection A is equal to empty set. Therefore, here empty set is called, or phi is called, the identity element. Idempotent law in intersection. A intersection A is equal to A. In addition with this, we have the one more different law in case of intersection. That is, A intersection B union C. A intersection B union C is always equal to A intersection B union A intersection C. Such a law is called distributive law. Now, exercise 1.4. These are the questions from the exercise 1.4. Find the union of the following pairs of sets. Let capital X is equal to 1, 3, 5. Capital Y is equal to 1, 2, 3. These are the problems taken from the exercise 1.5. We should find X union Y. X and Y are the two non-empty sets. The union 1, 3, 5 union 1, 2, 3. The union between these two sets is nothing but we have to select the elements which are belongs to A, or it is belongs to B, or it is belongs to both the sets. Now 1 is there in X and Y, therefore we have taken 1 over here. 3 is there in the first set and the second set also has taken one time. 5 is there in the first set and not in second set, but that is also a member of the union. Similarly, 2 is there in the second set but not in the first set. Therefore 2 is the member of the union of the two sets. Therefore the elements in these two sets are 1, 2, 3, 4. 4 is not there, 5. Therefore A is equal to A, E, I, O, U and B is equal to A, B, C. We should find the union between these two sets. Therefore A union B is equal to, first set elements are A, E, I, O, U union A, B, C. As I told you, in the union the elements are belongs to A, or it is belongs to B, or it is belongs to both the sets. Therefore A is there in both the sets, B is there in the second set but not in the first, C is there in the second set but not in the first. These are the members of the union. E is there in the first but not in the second, also a member of the union. I is also a member, O and U. Therefore the union between these two sets is A, B, C, A, E, that is E, I, O, U. Moving to the next question. Let A is equal to, this set is represented in the set built form X such that X is a natural number and a multiple of 3. B is another set containing X such that X is a natural number less than 6. Therefore these two sets we are going to represent in the roster form. Now the set A containing the elements A, we should find A union B. The elements of set A are X is a natural number multiple of 3. Therefore the elements of this are 3, 6, 9, 12 and so on. Union, the another set B containing X such that X is a natural number less than 6. Therefore natural number less than 6 are 1, 2, 3, 4, 5. One should find the union of these two. Therefore the union of these two is nothing but A union B is equal to, the elements of these sets are this set is 1, 2, 1, 2, 3, then we have 4, 5, then 6, then 9, 12 and infinite. Many elements are there because the set A is an infinite set. Therefore we have the infinite number of elements which are multiples of 3. Therefore the members of the union of these two sets is 1, 2, 3, 4, 5, 6, 9, 12 and so on. Moving to the next question. Sixth question from the same exercise. Find the intersection of each pairs of the sets of the questions given below. Let A is a set containing 3, 5, 7, 9, 11. B is the another set 7, 9, 11, 13 and C is equal to 11, 13, 15 and D is equal to 15, 17. We should find A intersection B. 3, 5, 7, 9, 11 intersection 7, 9, 11, 13. The intersection between these two sets is nothing but the common elements which are there in both the sets. Therefore 7 is there in both the sets, 9 is also there in both the sets, 11 is also there in both the sets. The elements which are there in both the sets, these are the members of the intersection of the given two sets. Similarly B intersection C. B elements are 7, 9, 11, 13. Intersection C elements are, it is 11, 13, 15. Therefore the common elements in these two sets are 11 and 13. Therefore the intersection between the B intersection C are nothing but 11 and 13. Once again A intersection C intersection D. The elements of A are 3, 5, 7, 9, 11. Intersection 11, 13, 15 and intersection 15, 17. In this case we have to take the elements which are there in all the three sets. If here 11 is there in the 3 is there in the first set but not in the second and third. 5 is there in the first set but not in the second and third. 7 is there in the first but not in there in second and third. 9 is there in the first but not in second and third. 11 is there in the first, second but not there in order as third. Therefore there is no common elements in all the three elements. Therefore the intersection of these three sets is an empty, which is denoted by the set curly brackets, empty curly bracket, or denoted by the notation phi. Moving to the next problem. by using distributive law. A, B, C already given to you. A intersection B union C is equal to the elements of the set A are 3, 5, 7, 9, 11. Intersection, the union between these two sets 7, 9, 11, 13. Union 11, 13, 15. We have to solve these two sets first. Now A intersection B union C is nothing but 3, 5, 7, 9, 11. Intersection, the common elements, that is union between these two sets, are nothing but the elements which are there in both the sets. Therefore 7, 9, 11, 13 and 15, these are the members of the union between B and C. Now the intersection of these two elements or the sets are 7, 9, 11, which are common in both the sets. Therefore 7, 9, 11. Moving to the next question, A intersection B union C, we should find. Now dear students, here we should write one change in the question. This member, this is not intersection, this must be an union. This element is intersection, it is an union. That is A intersection B union C it is. Make a correction in this problem. Now moving to the next question, A intersection B intersection B union C. Now let me find A intersection B. The elements of A intersection B are the intersection between the two sets. Now A and B are these two sets. The intersection between these two is 7, 9, 11. Now intersection B union C, the union between these two elements are 7, 9, 11, 13 and 15. Now the intersection between these two is nothing but 7, 9, 11. Therefore these are the members of the 7, 9, 11 are A intersection B union C. Now moving to the next question, A union B intersection D is equal to A is 3, 5, 7, 9, 11 union the intersection between B and D 7, 9, 11, 13 intersection 15, 17. Therefore A union B intersection D is equals to 3, 5, 7, 9, 11 union the intersection between these two sets is empty. Therefore the union between the empty set and non-empty set is always equal to the element containing. Dear students, once again there is a correction. This set is nothing but 3, 5, 7, 9, 11. Make a correction in this problem. The elements in the set containing 3, 5, 7, 9, 11 union empty set is 3, 5, 7, 9 and 11. Not an empty set it is. These are the elements of A union B intersection D. Now let me define the one more set, disjoint sets. The intersection between the any two sets is empty. Such set is called as an disjoint sets. For example, A 2, 6, 10, 14, B is 3, 7, 11, 15. Therefore A intersection B is equals to, there is no common element in both the sets, therefore the set is empty. The intersection of any two sets is empty, therefore A and B are called the disjoint sets. If R is the set of real numbers and Q is the set of rational numbers, then R intersection Q is non-empty set. Therefore R and Q are not disjoint. The simple meaning of the disjoint set is the intersection between any two empty sets as an disjoint set. With this I conclude my today's lecture. If you have any queries, please contact the given below number, or you can. Thank you. Stay home, stay safe.